Hello, everyone. My name is Sam Olson. I've been working with Olek and Paul with Reed College on some research improving the precision of forestry estimation. Now, when I initially got involved in this research, I understood what each of those words meant together. They didn't make a whole lot of sense. So one question that came to mind that really helped me understand what our research was getting at is the question, how many trees are there in Colorado? Now, you can turn to Google right now, type this in, and Google will give you an answer of about 11.7 billion trees. Now, that is a whole lot of trees. And one important thing to bear in mind when you create an estimate like this, we really want to know how certain we are about that estimate, what the precision is. So really focusing on that plus or minus. Because if we say we estimate there to be 11.7 billion trees, but we're saying plus or minus 10 billion trees, that's taking potentially a lot of wind out of our sails for what may be. That being said, this research we did on behalf of the US Forest Service. The Forest Inventory and Analysis Program, or FIA, is a branch of the Forest Service, and their job is to collect and analyze forest characteristics, like the count of trees in Colorado. The way that they actually create these estimates is using a method known as post-stratification, or Post-Strat for short. So what we wanted to do with our research is to assess the use of Post-Strat and two other estimators to see which one may come out on top and be the more precise estimator. So we were pursuing an empirical research. So of course, we have to have some data, and the issue is more what data do we use rather than what data is available. But out of all the different sources of data we have, we can bucket it into two main groups. The first being what we call plot level data. This is data that we actually have people go out to physical locations and measure how many trees there are, what the probability of forest is in a given area. And this is coupled with the second source of data, which we call pixel data. This is data that is geospatial, or GIS, and this gives us information like what is the elevation, what is the latitude or longitude, and so we combine these data together in order to create our estimates. One more thing to note before jumping into what these different estimators are, we were looking at a subset of the United States known as the Interior West. Broadly, this area is thought of as the states that use mountain time. So your Arizonas, your Colorado, your Montana, those were the areas of the United States we were focusing on. And specifically, we were looking at estimating county level estimates. So that being said, a high level overview of what exactly is going on when we say we're using Post-Strat. Post-Strat is a single variable. So on the right-hand side, we have Greg with that gray area, and we're just using one variable, a layer that we call our forest or non-forest layer. So what we wanted to do to try to bolster this estimation technique is by including multiple layers. So this is how we might be able to include things like elevation or height or percent forest cover. What we then did for our third estimator is we looked at expanding what the area being used is for creating that estimate. So again, on the right-hand side, we go from this small white area to this larger blue area. And the thought there is there may be an area that is similar to the area we're trying to estimate that we might be able to borrow strength from in order to improve our estimate. And in the field of survey estimation, this is what we call an indirect estimator because we're borrowing from outside the area we're estimating. This is particularly important when we want to do something like small area estimation. So instead of going for those Colorado estimates, we're going for those much smaller county level estimates. So with that, I wanted to then walk through an example of what this actually looked like in our research. And for that, we chose the county of Teton County in Idaho. So on the bottom left corner, we have this rectangle that has a number of different dots and colors. So the dots are representing our plot level data, the color of those plots indicating whether or not it is forest or non-forest. And then on top of that, we have our spatial layer, which is the green and the blue, again indicating whether or not it's forest or non-forest. So for Teton County, we have 50 plots and some 18,500 pixels that are all distinguished by whether or not they're forest or non-forest. So what we do is we take all of that data and we simply calculate a weighted mean for how much of Teton County is forest and non-forest, and for each associated one, what our estimate would be for that area. By contrast, we then move on to our second estimator, GREG. This is our generalized regression estimator. And you may notice on the bottom left-hand corner, the image really didn't change. And that's no mistake, because the GREG at a single variable is really the same thing as our post-stratification estimator. The advantage that GREG has, though, is you can add in all these additional layers, either continuous or discrete, of your other variables you want to include. So think of it maybe more as multiple rectangles, each rectangle representing another variable you're including in the mix. Now, our third estimator then was GREGORY. So this is GREG operating on resolutions of Y. The thought here being we now have the same rectangle as before, but now it's subdivided by a unique ecological province. So we see that Teton County is about 1/3 of one unique ecology, 2/3 of another unique ecology. So we're just running the GREG again, but we're doing it at each of those levels to then aggregate it to the mix that is Teton County. And the one important thing to keep in mind here is this is an indirect estimator. So this pink area can extend outside of Teton County, and the blue area can likewise extend out of Teton County, and then we just consolidate it back down when we create our GREGORY estimate. That being said, we have a number of results that we'd like to share with you. Importantly, before jumping into any of our graphs or figures, wanted to say that Olek made a really incredible dashboard that allows users to interact with the data and come up with these estimates themselves. And so these are all just screenshots from it. So before I jump into questions, I'll quick share that link with you. That being said, we were again looking at how precise these estimates are. So we were looking at the standard error of our estimates. And we see on the left-hand side there, our estimation method 1 is our post-strat. On the right-hand side, our estimation method 2 is our GREGORY estimates. And just by visual comparison, we can see that GREGORY tends to be more precise than our post-strat estimator. Now, we want to better understand where this may be happening, so mapped it out onto each of the counties. So our green is where post-strat is doing better, our blue is where GREGORY is doing better, and we also have some NAs because of dividing by zero errors. So from here, we consolidate this down to just simple numerics. We have 213 counties that were improved out of the 256 that we actually have a relative efficiency of. So this accounted for about a 82.3% improvement rate of counties. So we have some preliminary evidence that GREGORY is a more precise estimator than post-stratification. And so we did some additional testing, but generally that conclusion held. So with that, wanted to give special thanks to everyone who helped support us, and also special shout out to the many foresters that physically go to locations and collect the data that was really invaluable to us. So with that, we'll jump into questions after I share the quick link.